When we started doing this project, it was right around the 30th anniversary of the devastating earthquake that affected Haiti.
We traveled to Haiti to get a first look on the perspective of how people perceived aid and how they believed their quality of life can be improved.
Then we started researching and researching and researching.
And then we realized that we could come up with an integrated model for sustainable development. But we need something else. And that something else was the educational model.
We thought that to help the Haiti was to give them a technical education program that would help them rebuild their nation. At the end, we came up with a project that, although it's broad, it brings together a lot of ideas into one single project.
Our project began with the interest in combining solar, wind, and hydropower into an integrated and affordable system that can help developing nations.
This idea is different because it's an integration of different projects into one.
It involves safe housing, renewable energy, waste management, and food security. So everything gets tied in together with different systems, and it all circles back into education.
We are a university, and as long as we are a university, we think we can help a lot with that educational model.
So the dialogue in the world is obsessed with the energy crisis, but water crisis is something that's looming in many parts of the world. The water crisis already exists.
One of the things that I see happening in the world right now is massive overpopulation and population density occurring in cities. When you have high population concentration, you have water scarcity.
This project is about using sunlight to drive a chemical reaction in reactors mounted on the side of a building to treat wastewater created in that building and recycle it directly at the point of use.
If this could be implemented in these buildings, not only does it make the buildings themselves more sustainable, not only is it using less water, using less energy, but it's also reducing the load on our already kind of overstressed systems in the developed world.
Part of our project is to really focus on the issue of energy. So we want to utilize solar energy and use this to recycle water. Although water does not disappear, it has to be cleaned, it has to be purified.
Purification is relatively easy to do with a small bit of filtration, and in our project we use photocatalysis, which is what happens when sunlight hits titanium dioxide. It generates free radicals that kills bacteria in the water very simply, effectively, and rather quickly.
It has two kind of distinct pieces that are being synthesized, and that's kind of the strength of the project, is the synthesis. It has the engineering aspect, which is the actual chemical processes and mechanical processes by which the gray water is being treated, and has the building scale aspect of the project.
Why I love this project is it brings actual water treatment and recycling to the forefront and makes it an integral part of a building's appearance. And to me, that brings sustainability to the front, and hopefully it can drive larger behavior change around sustainable ideas.
The project is started as a research project. Basically, we're looking for low-cost feedstocks for biodiesel.
We ran across the biodiesel production project and we said, hey, this looks like a great project to look into. And so we started looking further into how we could commercialize it and turn it into a technology that would affect the most people and do the most good.
The biodiesel market is on the rise. Production in the United States is hovering around 1 billion gallons a year, and that number is growing. So what we do is we take fats, oils, and greases from essentially sewer systems.
The reason why we pick up trap grease is because currently the biodiesel producing rely on the oil crops, which actually consumes a lot of resources to grow.
Anywhere that people are consuming, this is becoming a waste that's growing and growing.
So if we use trap grease, which is a form of waste, we basically eliminate the resource and energy consumption that's put in the growth stage of those materials.
Currently, most of the biodiesel in America comes from soybean oil, which is an agricultural crop. This means that there's a lot of expenses involved. There's land, there's money, there's water, there's people. So with the technology that we've been developing at the University of Cincinnati,
we're able to use a waste product to actually extract other waste products and use both to create biodiesel.
It will be beneficial in several aspects. Firstly, it's going to improve the sustainability of biodiesel production.
I see it impacting so many people because it can be used anywhere that there's industrialized society.